Dzień dobry. My name is Ken Budka, or now that I'm back in the motherland, Ken Budka. Both my great-grandparents from both sides of my family came from Poland. My mother's side from Nowy Targ, and it is a great pleasure for me to be here to speak to you about what's happening in the energy industry, in particular, the communications that are going to make the next generation of energy and energy services possible. This is a high-level view of a traditional power grid. And the power grid has not changed very much since the early days when Thomas Edison first proposed the grid. We have very large sources of bulk generation, either through fossil fuels or nuclear or hydro. That energy is pushed over a series of transmission systems, very high tension, high voltage power lines that efficiently deliver the power to distribution systems. The distribution systems in turn deliver the energy to the homes. This system has not changed very much, and one thing about energy is that as soon as it's generated, it has to go somewhere. And today we don't have a lot of storage. There's some storage either in the generation side or in the distribution side. There's very little of it, and it's very expensive. And that energy we have to coordinate the generation and the consumption of energy. And communication networks today play an important role in achieving that balance between supply and consumption of energy. And there's really a few small applications that make the grid today work in a safe and secure and reliable manner. Teleprotection. We have these lines of very, very high tension power. Should there be a problem in that delivery of power, you need to very quickly turn off the energy so that the energy no longer flows and causes a safety risk. Very, very highly reliable, has to happen very, very fast. We also have systems to actually control the elements in the grid themselves, the generation, the transformers. And we have a system set up to monitor and control these devices. It's something called Supervisory Control and Data Acquisition, SCADA systems. We also, utilities are strong users of wireless systems to coordinate workforces, to talk to one another, another system. And they're also users of enterprise data, email, data centers, and such. If you look at the grid today and the communications networks of the grid today, they're very much, there's a small number of endpoints that need to be controlled. A very small number. And the networks tend to be very siloed. You have a network to talk to generation, a network to talk to distribution, a network to talk to video cameras. This is a very, very inefficient way to do things, but with the small number of endpoints and the small amount of control that's happening, it works pretty well. Also narrowband radio. And most of the communication happens between very large data centers and control centers and substations in the field. Now there are some things that are fundamentally changing and disrupting the way that energy networks are built and will be built in the future. First speaker talked a lot, Mr. Gall just talked a lot about distributed generation and storage. We're moving now from a place where we have very large centralized bulk generation to an environment where we have lots and lots of smaller generation. Solar cells on people's homes, neighborhoods sharing solar infrastructure and sharing battery infrastructure. That does two things. One, it creates a large number of devices. These devices need to be talked to, need to be controlled, need to be monitored. And it also creates a lot of variation in supply and demand. And this is something in a grid we need to be able to always match supply and demand. Communications play a significantly important role in making that happen. We're also moving to a world of prosumers, so households that not only consume energy but generate energy. We're seeing the move of meters to the home. These meters are not only there for billing but also to control, to monitor, and to manage the flow of energy. We see a tremendous amount of sensors now that are being pushed out into the grid to maintain stability and to maintain quality as we move to this highly distributed system. We also see new applications, and new applications that are being introduced not only by the utilities themselves, but by other companies that are managing information, managing energy for prosumers. And we see new security threats. Devices that now are going out into the homes, out into the world. These are nice places to attack if you are a bad guy. So smart grid and all of the changes that are, the forces that are driving change in the grid have a tremendous amount of impact on the way that we think about building networks, building grid networks, and also the communication networks to make them all work. First of all, an explosion in the number of endpoints that need to be monitored and controlled, up to 1,000 to 10,000 times more than we see today in the current grid. Also, lots more bandwidth that is needed to talk to these devices, to collect the information from the devices and make that information accessible to other places. A tremendous amount of data that needs to be stored and managed. Also, a tremendous variability in the supply and demand. And a need for universal connectivity. Not only connectivity from data centers to transmission and distribution substations, but actually to the home or to the wires in the field. That creates a tremendous drive for communications. Also, not all applications are alike. So the applications that protect the safety of the grid, that turn off the power immediately when there's a fault, those have very, very stringent reliability and quality requirements. Some applications, getting some billing information, not very important. The new grid needs to be able to manage all this information, to know what is critical and what's important and know what's not. So this is our view of what the communications grid of the future looks like for smart grid. At the heart of any control infrastructure, and you see this today, is a very high quality, highly reliable, resilient, high capacity optical network that interconnects primarily substations, control centers, data centers, your major generation sites. That is the heart and soul of a communication network. It's the heart and soul of a control grid. But that only gets you part of the way. It gets you to the substations that you can control, the heavy iron. Much of the evolution, much of the revolution that's happening in energy is beyond the substation and closer to the home. And getting to those points is often the most expensive part of building a network. And there's not one size fits all answer for that last mile. You have different economies in rural areas than you do in urban areas and suburban areas. You also have different legacy technologies which could be used for this purpose. So here at what we call the field area network, this is where we're using a variety of different technologies from wireless services that are offered by commercial service providers to wireline services to leased lines, also private networks that are deployed by utilities explicitly for controlling devices at that last mile end. And that last mile is where a lot of the innovation is happening in smart grid. From distributed automation, electric vehicles, microgrids. These are going to be neighborhood size or enterprise size or even home size grids that generate power, store power, and becomes the place where energy is traded with the larger networks. Also, advanced metering infrastructure, meters, distributed generation, all of that needs to be controlled and managed. Also, connections out to remote substations. And this is happening today. We're moving to an all IP infrastructure, internet protocol infrastructure, but a network that is built for the purpose of reliable, scalable, mission-critical communications. Using a technology called IP-MPLS. IP-MPLS is a technology that takes a fairly unreliable service like internet and makes it highly reliable so that you can run these very, very mission-critical applications on top of it. This modernization wave is also now hitting the substations. So the substations themselves are becoming a network of computers that need to talk to one another within the substation and also between substations. And this wave of modernization is just beginning to happen in Europe and also Asia, parts of the US, where we're taking a lot of the internet concepts and bringing them directly to the substation so that devices can talk machine to machine with the proper reliability and quality and security. Also so that we can bring in additional security devices directly into the substation to monitor for intrusions, to protect from intrusions, also to provide video surveillance so that we know what's going on in remote parts of the network. It's also a place where we're providing access to field personnel as they come to service the substation. We are currently involved in a research trial. It's actually being fielded right now in France with RTE, where we're taking this next generation digital substation and making it real in the field using proven networking and communications components. Also just want to talk about some things that are happening in the rest of the world that might have some bearing on things in Poland. This is a project I've been working on personally for about 5-6 years now. In Chattanooga, Tennessee, Chattanooga is a moderately sized city in the United States. This city currently has the highest broadband rates of anywhere in the United States. Over 1 gigabit per second going to homes and businesses in the Chattanooga area. EPB is a municipal utility. That means they're a utility that provides not only energy distribution services, but also telecommunications services. Using a grant from the federal government, they built a broadband fiber network throughout their entire grid, which provides services at 1 gigabit per second. And this fiber optic grid is used to both provide personal services, cable TV, HD TV, very high rate data, as well as the electric side to read meters, also to provide supplementary services like demand response and other smart grid applications. Now, one of the interesting things happened when Chattanooga built this gigabit network. All of a sudden, they had the fastest internet in the US. It started to attract companies like Amazon that began to site their large data centers in Chattanooga. It also spawned a whole cottage industry of doctors that looked at x-rays, all very high data rate activities. They started doing business in Chattanooga. So side effect was economic development from all of this high-speed internet services. We also partnered with Chattanooga to begin to see what could be done with all of the data that is collected in this smart grid. Every house has a meter that reports consumption every 15 minutes. All of the substations are monitoring and managing and providing information. Also, we have access to temperature information that is needed to both predict power consumption, to respond to events, to respond to failures, to be able to more efficiently manage and monitor the grid. All of this can be mined from the big data that is now in the hands of EPB to make their grid more effective and more efficient. The other thing I want to point out is this is a mix of technologies. So you see, when you reach that last mile is the most expensive part of building a network. Not all of the customers in Chattanooga have subscribed to this triple play voice, video, and data service. So those that have a fiber going directly to their home. Those that don't have a meter that communicates wirelessly to homes that actually do have connectivity to the net. Something called wireless mesh. So we see all sorts of interesting things happening at the edge where these technologies begin to be combined. There are also introducing distribution automation applications to be able to detect failures and quickly reroute power in the event of an outage. That has significantly increased the reliability of the electric grid in Chattanooga. Also, we view a world in the future where this information is not only consumed by the electric utilities themselves, but a new world where new entrants come to manage data, to use data, to better control the grid, to better incorporate renewable energies, to allow people to trade energy with their neighbors, with their broader community. In order to do that, we need a very secure and reliable way for information to be shared. I wear two hats. So one hat I wear is working with our businesses that are looking to grow into new areas. The other hat I wear is in our research laboratories, Bell Labs, where we develop new technologies. We've developed a new technology that allows end user devices and machine devices to be able to encrypt their device, encrypt their data right at the source, and share that information only with a set of users that are allowed to consume that information. This is a basic building block in the energy network of the future. To be able to get access to information, to be able to distribute information, to be able to control information is a basic building block of billing systems for meters, for energy trading, for prosumers, for storage systems, all the systems in the future that need to communicate. It also opens up application interfaces to new companies to come in and innovate and to use this information to control and create additional value for the economy. This is a consortium right now. This is a trial network in Belgium. We are using this software and mounting the software on grid control and monitoring devices in a trial network where we're actually trading energy, controlling energy, and monitoring the network in real time. So just in closing, the future of a smart grid relies on innovations in a variety of spaces. It relies on innovation in the grid side for new transformers and new semiconductor devices. Also, new renewable sources, new ways to store energy. But fundamental to the grid of the future is the ability for all of these devices to communicate with one another so that these devices can create a reliable, scalable, economical energy source. And this communications networks are at the heart of this transformation, and we are pleased and proud to be part of that transformation. It's also a place where you see a lot of new disruption happening, which makes it very, very exciting. Thank you very much. Dziękuję.